Good afternoon, listeners. This is Hammer the Scammers Group, and our pitch is based on Challenge 3, e-safety, cybersecurity, and cyber safety, focusing on the voice phishing threats. With the, as said in the title, phishing detection using GPT-3. Okay, so what is voice phishing? So voice phishing is defined as a phishing attack that consists of using voice calls through phone and VoIP systems in an attempt to grab or gain financial advantage over a victim. Voice phishing reports through the ACCC. Based on the left side, we can see in 2019, phishing attacks were reported amount lost of 600,000 and 8,000 reports recorded. Compare that to the center on the graph on the center, which is in 2021, which you can see based on there's a significant increase in the amount lost and the amount of reports recorded compared to 2019. And as we can see on the far right graph, which is the age groups, we can see that lots of reports are being occurring through people aged over 65.
Hi, this is Rahul. So I will be talking about the data set and the app's approach. So the first problem we faced was there was no English data set made for CDR calls. So I thought of two approaches. One thing we can do is translate a Korean data set. There was a paper on that for voice phishing. We can then create embeddings for them using GPT-3 and store them in a lake. Otherwise, we can also harness the power of GPT-3's augmentation capabilities to augment more data set from a small amount of transcripted data, and then use the GPT-3's embeddings to store in the data lakes. So this is the app structure. The first thing that happens is the elderly person gets a call, and the number is searched in the contact. If it does exist in the contacts, then the call is ignored. If it's not, then the call is transcripted, and the received call, the transcription is for 30 to 45 seconds, which is then sent to a similarity matching model. If the similarity is very high, then there's a high chance that this call is a scam call. In that case, the call disconnects, and it reports to a nominee that the person selects. And if the nominee accepts that this is a scam call, then the embeddings are saved into the server. If the similarity is very low, then the call continues as the app thinks it's not a scam. Thank you.
This is Yash, and what we're doing here is we are sending the encrypted data to the server with information about the data, and we are ingesting it in real time. And then we are sending it to the MongoDB server, the text data, and we are using GPT-3 model for embedding. And we are again integrating it with the information about the data, and we are sending a report to the nominee. And on the other side of the lake, what we are doing here is we are analyzing the data and we are visualizing it. To secure this part, what we can do here is we can use single sign-on techniques so that our analysis, our visualization is not compromised. And to secure a server, we can use encryption method so that our server is not filled with garbage values. Thank you.
Moving on to the security assessment of the application, this would be the four main concerns. First of all, the data when being transferred from the app to the data lake might be intercepted, tampered, and compromised by attackers. So the solution would be enable encryption with transport layer security when the data is transferred. Secondly, it's a common issue regarding AI algorithms that would be false positives and false negatives. It is almost impossible to not get any of them in an algorithm. So the most optimized thing we can do is to minimize them to the smallest amount possible. Thirdly is possible call eavesdropping. With the presence of a third-party app during calls, it would be more vulnerable to eavesdropping, as it provides another way for attackers to eavesdrop calls. So to limit this, calls using the app will be encrypted on both ends. And finally would be data privacy concerns using the app. The information that will be collected by the application are the person's name and phone number, the person's contact directory, the person's nominee, and finally the application will also be able to listen to the calls.
In relation to our UI and UX, as we can see through the diagram, that once the incoming unknown number has been reached after 30 seconds, a message like this shown below will be sent sending the actual what was received and the input data based on that. Business model. So basically feasibility, economic value, social value, and stability. It is fast, reliable, and can produce highly accurate results. economic value, a cost-effective solution, which thinking about the amount of money that is being lost every day due to the voice phishing attacks. It provides a lot of social value, protecting elderly people who are of most vulnerable people to the phishing attacks. And finally, human capabilities are preserved by leveraging the capabilities of the AI. Our project was heavily influenced by the research project of the Korean voice phishing, where they aimed in real time through machine learning models and NLP processing techniques to detect phishing calls, and this was a success with 100% accuracy through all models. Final notes, and we expect more data, we increase demographics, there's new markets, adding more servers and increasing connectivity, applying more security developments and knowledge graphs. Here's references, and thank you. Any questions? Thank you very much.